If I give you two numbers, let's call them 2 and 4, and I ask you to put greater than, less than, or equal to there, the greater than sign looks like this, right? The less than sign looks like this, and of course the equal sign you all know looks like this. So which of these symbols do you need to put in here? Well, you know they're not equal, so you can't put the equal sign in here. The way you decide what symbol to put in there is extremely simple. It's very simple. I'm going to tell you the secret. Not all teachers will tell you this, but I'm going to tell you the secret, okay? The arrow for the less than or greater than, the arrow, it always points to the smaller number. Always, 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 always. You point that arrow to the smaller number, and then you will always get the right answer. All right, so in this case, because I have a 2 on the left and a 4 on the right, I'm going to point it this way because the arrow always points to the smaller number. Right? What if I have, let's say we have 7 and, I don't know, we'll put 3 over here. Okay? And I'm asking you, which way does the arrow point? Well, I don't even have to think about it. It always points to the smaller number. So the way you read this is 2 is less than, the tip of the arrow means less than, 2 is less than 4, and the big part of the arrow means greater than, so 7 is greater than 3. So that's how you read this. And those all make sense, but sometimes people get confused on which way the thing needs to point. You just need to remember it always points to the smaller number, always, all right? Now what we're going to do is do exactly the same idea, but instead of whole numbers, I'm going to give you decimals on both sides of the symbol, and you're going to have to help figure out which direction it points. So it's not a hard concept. We just need to get some practice so that you can get comfortable with this. So if I give you the number 1.4, and I also give you the number 1.5, you need to decide, am I going to put greater, less than, or equal to? Well, you know it's not going to be equal to. The first digit is the same, that's true. And then we each have a decimal spot, a decimal point. But the 4 and the 5 are clearly not the same number, so they cannot be equal. So you're not going to do that. So what you need to do now is figure out which one is going to be greater than, which one is the bigger number, which one is the smaller number, basically. So you start looking at digits. You compare the first digit of each one. Well, they're exactly the same, so I can't make a decision there. So then I go to the next digit, right, after the decimal point. Now we're looking at numbers that are after the decimal point. So here we have a 4, here we have a 5. There's only one digit after the decimal. This one is the smaller number, and there are no more digits to look at, so we always point to the smaller number. All right, so first, the way you do this is you always look at the numbers before the decimal point, and if you can clearly see that one of them is bigger or smaller because of the numbers in front of the decimal point, then you can go ahead and point the arrow. But if all the numbers are the same that before the decimal point, then you have to look at the numbers after the decimal point. All right, so let's get a little more practice. What if we have 2.6 and 5.2? Which way do we go? Well, first we look at the very first digit. This is in front of the decimal. We have a 2 and a 5, right? So we could look at this digit, but it really doesn't matter because this is in the ones place. So this is worth 2. This is in the ones place also, and it's worth 5. So it doesn't even really matter what's after the decimal. The 0.6 and the 0.2 doesn't even really matter. This one is already smaller because he's got a 2. In fact, if you were just to cover up the 0.6 and cover up the 0.2, you would have 2 and 5. You already know which one is bigger, which one is smaller there. This guy's the smaller one. All right? Even though the 6 is there and 6 is bigger than 2, that doesn't really matter because you always look at what's in front of the decimal first, because those numbers in front of the decimal are worth more. Remember, we talked about that when we talked about decimal place value. All of those digits that are in front of the decimal are worth more than all the digits that are after the decimal. So because this guy is a 2 and this guy is a 5, then it doesn't even matter what's after the decimal. This guy's always going to be the smaller number. All right? So make sure you understand that concept. All right? So let's go and just kind of rip through a bunch of problems here. What if we have 1.4 and 1.04? So now we have to compare, and we see, well, in front of the decimal we have exactly the same number, so we have to then look at the numbers after the decimal to make a decision. The first digit after the decimal is 4 over here. The first digit after the decimal here is a 0. So even though there is another number over here, we can kind of stop because we've gotten to the last digit here, and the last digit here, and we can determine that this guy is a 4 and this guy is a 0, so the smaller number is actually this one. Right? Another way that you can kind of, if you need to, another way that you can kind of think about this is, after a decimal point, you can put as many zeros at the end of these numbers as you want to. So after a decimal point, I can put as many zeros here after a decimal point as I need to help me visualize. So since I have 2 digits after the decimal here and only 1 over here, I can always add like a little invisible 0 here after the numbers that are after the decimal point. So here I have 2 digits after a decimal and 2 digits after the decimal. So I can, it kind of helps you sometimes, depending on how you learn, if you can see the same number of digits. You have a 4 and a 0, okay, this guy clearly shows that this one's the smaller number. I don't even need to go to the next comparison, 0 compared to 4. I don't even need to do that because all I'm doing is I'm looking at each digit, comparing as I go across. And whenever I determine which one is smaller, then I have to draw the line and say, well, that guy's a smaller number, and I just go ahead and draw my arrow. Okay, so let's get some more practice. What if I have 1.4 and 1.49? So same kind of thing. I start in front of the decimal. These are the same, so I cannot make a decision. These are also the same, so I cannot make a decision. So then I get to a 9, but I'm confused for a minute because there's nothing here. Well, I'm kind of telling you that there's always an invisible 0 that you can add after decimal points. After any digits that are after a decimal, you can add zeros there without any problem. So here is the same number. You can't make a decision. Here's the same number. You can't make a decision. So far, they're equal. When you get to here, clearly this is the smaller number, 1.40. So we point to the smaller number. So that's basically what you're going to do, digit by digit comparisons until you figure out which one is the smaller number. Let's go walk over here and take a few more. What if I have 0.85 and 0.86, and I want to figure out which one, if I need to put greater than, less than, or equal to. I start before the decimal point, and I see 0 and 0, so I cannot make a determination based on that. So I go after the decimal, and I say 8 compared with 8, can't make a determination based on that. So then I go to the next digit. I see a 5 here and a 6 here. This is the smaller number, so I point that way. What if I have 1.76 and 1.67? Okay, so I start here and I say, well, the digit in front of the decimal I have is a 1, cannot make a determination on that because they're the same. So then I go after the decimal, I see a 7 compared to a 6. I don't even need to look at any more digits. Once I get to one that's different, I can point to the smaller one because the 6 is less than the 7. What is over here really doesn't even matter there. So we're just kind of getting our practice here. What if we have 54.2 and 49.3? Which way does it point? Well, I compare the 5 and the 4. They're not the same. 4 is less than 5, so I immediately point that way. And that makes sense. I mean, think about it. 49.3 is going to be less than 54.2. You know that because 49 and plus anything, a little bit, decimal, anything is going to be less than 54 point something. So the way to do it for every single problem, though, to make sure you get the right answer is go decimal by decimal and just do the comparison. All right, what if we have 2.7 compared with 2.70? What do we put in between here? We look at the first digit, they're the same, so far they're equal, can't make a determination. After the decimals, those are the same, so far we can't make a determination. Then we try to compare this with this, and we have a 0 and nothing there. But as I've already said, after a decimal, you can add as many padded zeros at the end that you need to. So we have 0 compared to 0. These guys are exactly the same number. 2.7 and 2.70 is exactly the same number. You need to kind of get used to saying that. In fact, 2.7 is the same as 2.70, which is the same as 2.700, which is the same as 2.7000, which is the same as 2.7000000. Doesn't matter how many zeros you add after a decimal that are after the last digit that comes after a decimal. You can add as many as you want, and it's the same number. All right, it's the same number. All right. So let's go on and continue gaining a little bit of practice. So we have 3.9 compared to 3.900. So after this discussion, you should see, even without doing anything else, that the 3 and the 9 are the same, the decimal's in the same place. We have an extra 2 zeros here, but we already said that it doesn't really matter about the extra zeros that come after a decimal point at the end of a decimal point, the very end of a decimal point. So we can kind of add some invisible zeros here ourselves to prove to ourselves that these are the same number, and in fact they are. All right? Now, I want to make sure and clarify something before you get confused. When I say it doesn't matter how many zeros you add after a decimal point, I'm talking about trailing zeros that are very, very end of the number, after any digits, okay? Clearly, if I have a number like 1.402, this zero does matter. 1.6009, these zeros matter, okay? You can't just add zeros anywhere you want. What I'm talking about are, anytime you have a decimal like these numbers here, I can add zeros at the end. After all of the digits are printed, I can add any zeros at the end and it won't matter. It won't affect the value of the decimal. All right, so just keep that in mind. So, what if we have 5.012 compared with 5.07? So same kind of thing. What we're doing is we're comparing the 5 with the 5, those are the same. Then after the decimal, the 0 with the 0, those are the same. Then we compare the 1 with the 7. 1 is smaller, so we point it that way. This is the smaller number. Okay? What if we have 24.06 compared with 2.406? Now, this is a great question because it can get people confused sometimes. If you glance at this question really fast, you might say, well, these are the same number because I have the 2 and the 2 and the 4 and the 4 and the 0 and the 0 and the 6 and the 6. You might say these are the same number. But you have to look at the decimal point. The placement of the decimal point is different, okay? So if you just forget about everything else, the decimal point is here, then I have 24 pizzas plus a little bit more. Here I have 2 pizzas plus a little bit more. So even without doing anything at all, you know that this one is the smaller one because the number in front of the decimal just means that's the whole number part of it. It's only 2. The whole number part of this number is 24. Of course this is the smaller number. It doesn't even matter what's after the decimal. All right? So the placement of the decimal dramatically changes what the value of that number is. So you have to make sure and look at it. So you would be comparing the 2 with the 2, and then you notice that you have an extra digit in front, and then this one's over behind, so you immediately know this is the bigger number. All right? What if you have 154.2 compared to 15.42? Again, they look the same. 1 is the same as 1, 5 is the same as 5, 4 is the same as 4, 2 is the same as 2, but the decimal points are different between the two, right? So that changes everything. This is 154 plus a little bit more pizzas. This is 15 pizzas plus a little bit more. Clearly, this is the smaller amount, okay? So comparing the numbers, the 1 and the 1 are the same, 5 and the 5 are the same, but then I try to compare the next one. I see I have an extra digit over here, so clearly this is the bigger number, okay? What if I have 7.9 compared to 8.056? Which direction does the arrow point? Well, I compare 7 to 8, and I don't have to do anything else because that's in the numbers in front of the decimal. There's only one of them. This one is smaller because 7 is smaller than 8. What if I have 8.4 compared to 8.397? Which one's going to be the arrow that I need to put in here? Well, 8 compares with 8. Those are equal. I have a decimal. That's the same value, same location, so that's fine. Then I go to 4 compared to 3. The 3 is the smaller number, so the arrow points that direction. And here's our last problem, 0.67 compared to 0.607. Again, students might look at this and quickly, without thinking about it, say they're equal because they look at the 6.7 and the 6.7 over here and they say, oh, those are the same. But they're not the same because I have a 0 here. So let's go step by step. 0 compared to 0, those are the same. I have my decimal in the same place. The 6 compares to the 6, those are the same. The 7 compares with the 0. Those are not the same. 7 comparing with the 0 is smaller. So this guy's the bigger number, this guy's the smaller number, and the arrow always points to the smaller number. I lied to you a little bit. We have one more problem, 8.65 compared to 8.56. So again, if you're reading a problem really, really quickly, you might say these are equal because you have 8, 6, and 5, 8, 5, and 6, and you might just quickly say they're equal, but they're not equal. 8 compares with 8, those are equal. Decimal is in the same location. 6 compares with 5, 5 is smaller, so it always points to the smaller number. So the fractional part that you have over here is smaller than what we have over here, and that's what makes it smaller.